what we're going to talk about today is RavenDB. This is an introduction to RavenDB, and that is as far as I have in far of prepared remarks. What we're going to do now is we're basically going to build an application from scratch using RavenDB, and that's about it. Before we do that, do you even know what RavenDB is? I know that Sebastian talked about it a bit in the morning. Someone can tell me what RavenDB is? It's a document database, exactly. What's a document database? SharePoint? Dear God, no. You're used to thinking about databases in terms of relational terms. But RavenDB doesn't work in terms of relation. It isn't limited to rows and tables and columns. You can store arbitrarily complex data inside of RavenDB. So let's start with the most simple thing first. Let's decide on a model. What sort of a model do I want to store for the demo? Someone give me a model. I will choose a victim. Okay. We'll go with courses. So I didn't hear you? We don't want that. We don't want that. So we have course. What do we have about the course? More? This is good enough, right? A good start? Right here, I have a base controller. Right now, let's not worry too much about what it does. The important thing is that gives me a session. This is an implementation of the same architecture that I talked about before. So I'm using here MVC application. And I'm just going to create MVC controller and throw some JSON on the screen so we can see it easily. Course controller. Inherit from Raven controller. New course. And looks good enough, right? Is there anything else that I need to do? Well, if I was running a relational database, what would I have to do? Yeah? Sorry? Okay, this is actually handled here. So let me just show what's going on. Here we have the document stored. This is the connection. This is the, in an Hibernate, this is the session factory. This is what you use to get a session into the database. Or if you want me to use ADO.NET terms, this is what you use to create a connection to the database. And this is how we do it. Okay? What else do we need to do? So I actually went ahead and created a database. What else? So I would actually have to start creating the schema, creating the columns, setting up the mappings, all sorts of stuff like that. I don't feel like doing that. courses/create. What? Course. Oh, look at what happened. You see this? What happened? Guys, I have data inside the database. Just like that. I know. Let's do something. Let's evolve our data. I want to change the course somehow. How do I do that? Let's add a property. Sorry? So what am I going to do? Let's add this is a good one. And RavenDB, NoSQL. And we run it again. And we have another one. And here's another one. We actually only showed the most common columns, so you won't see it here. But let's go inside and look how it looks like, okay? So far we have seen the tabular structure. Now we are actually seeing how it looks like. What is this format? This is JSON, JavaScript Object Notation. And we have one document like this, and another that looks like this. Notice that they are different. This one doesn't have a tags property. So not only didn't I have to create a schema, I didn't even have to migrate anything. It just works for me. But you know what? This is something I really hate. How many of you have fields like that in your database? Anyone? Delimited fields, comma separated, space separated. I once saw a field that was this, I don't know what this character is, but it was separated by this one. And I hate that. What's the problem with field like that? It's awkward to work with. How would I like to work with something like this? Guys? I want a list. And this is just for my own comfort. Just as an example that we don't have to worry about spaces now. Now let's create this one. And where we are, here it is. Now look at what happened. What are the result of the tags? Now we have a list. You know what? Let's do something slightly more complex. Okay, we have requirements, and a course now have and another requirement for, let's say, honestly, this is me just having fun here. Everyone can read this? What did we just do? Yeah. Okay. Now we have a list of objects. Now we had a list of complex types. What are the implications of doing something like this? Guys, what are the implications of being able to store things like that? Yes. Okay. Yeah. I don't need an ORM mapper. Yes. Guys, how many tables am I going to have to deal with in this? If I want to store this in SQL? 3, probably 4, because that would be an association. And it's ridiculous. Let's talk. If I want to show the course page, I would have to touch 3 or 4 tables just to show the page. Now, granted, we write so much more often than we read, so it doesn't matter, right? I mean, obviously, we're going to write 100 or 1,000 times more often than we read. What is this silence? Yes or no? No? Why no? Tell me it isn't so, because, look, if you want to tell me that I read more than I write, seriously? But how many of you use relational databases? Okay, so pretty much everyone. Problem. How come relational database are actually optimized for writes and not for reads? Relational database allows you to do writes very easily, but if you want to do read, you have to do joins and multiple queries and all sorts of other stuff like that. Sorry? Again, storage when they were created was extremely expensive. So, by the way, I'm just going to throw them. Oops, sorry. Yes. So, storage was very expensive, and it made sense to make people wait for the right versions. It made sense to make people wait for the answer because the storage was so expensive. Remember, I showed you the 10 megabyte hard drive that cost $5,000. So, in RavenDB, instead, you have it like this. How costly it is to read it from the database? It's just one call to one object. Let's try to show this on the screen. Yes? Wait for it. So the first thing, so I created some courses, that's nice. Let's just, 1 second. What I want to do now, I want to delete the courses and stay with just one course. Wait, I want to delete, yeah. Good, so now I have this one. Nothing, it's just that I want, my problem is this. It has a space in it. I don't want to deal with queries that have space in it right now. I want to do it just like this. But to answer the question, it would just fill in empty value in the missing properties. So we now have this guy again. And what I want to do now is to public object load int ID, return JSON, load course, okay, you see that this is actually the Microsoft JSON parser, JSON serializer. So this is how it thinks that you should deal with what's called with time spans. But it's basically 2 days, and it's really annoying that it looks like this. But you see that this is what we actually had to do to load an object. And this is a complex object. It has collection. It has collection of complex objects and stuff like that. Now, this is easy, right? What I'm basically showing you is RavenDB storing a text file. Let's do something more interesting. I want to now be able to search by tags. How do we search in .NET? So many of you are using Hibernate. Do you know the feeling with Hibernate when you have session and you press dot and IntelliSense open and open and open and open? Allow me to show you how it works with Raven. We have like this: delete, include, load, query, save changes, and store. 6 methods. And we have advanced where all of the crazy part goes, but you don't have to go there. Yeah, the fun part is that of all of you who use Hibernate, how many of you use the method refresh? 1, 2, 3, evict. 1, 2, 3, pretty much the same guys. Merge, anyone ever use merge? The problem with Hibernate, you need all of those things. With Hibernate, they're right there in your face. With Raven, we said, okay, we have multiple levels. First level is for CRUD stuff, the things that you do all the time. Then you have the things that you need once in a while. So we're going to query a course, and let's do this. Where c.tags any is there anyone here who can't follow this code? Right, fairly simple. Let's see if this works. I'm actually running live demo here, which is yeah. Oh, we found it. NoSQL 2 didn't found it. So just to give you some idea, in SQL, that would be do a join to a nested to an association table and find the value back. Now here is an interesting question. How many of you ever brought down SQL Server in production because you run an unindexed query? Anyone? How many of you brought down a SQL Server in production for some reason or another? Yeah, so we have about 1/3, 1/2 of the room. And what happened? How come you, what happened to kill SQL Server in production? Sorry? No, what caused the problem? Mm-hmm. Mm-hmm. Okay. Something else. Another reason SQL Server died in production. Oh, yeah. That's fun. That's a lot of fun. Yeah, it's fun in the same way that going to the dentist is fun. Another common problem is when you have a query and it isn't using an index, and for a while it works. Do you know that feeling? It works until you have enough data. Suddenly, beep, 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 boom. No more database. And it tends to happen, I swear, it tends to happen just at the most inconvenient moment. It never happens when you have a slow day and nothing to do and you consider going to the beach. It always happens when you actually have so many other things happening at the same time. So with RavenDB, wait a second, well, did we do something to the server, by the way? We didn't, right? Yeah. Sorry? This one? Because the default approach is to say that humans don't think in case-sensitive manner, and there isn't any reason why to force you into case sensitivity. So in general, RavenDB is case insensitive for queries and most things. So we didn't do anything on the server, right? So if you were doing this sort of query in SQL, how would the database process this query? Full table scan. Now, full table scan are dangerous. They're dangerous because they're so easy to, they basically kill your application very easily. So instead, what I decided to do is say, we don't allow any unindexed queries in Raven. It's nice that we don't have any unindexed query with Raven because we don't have table scans. And that means that all of the queries are always fast because they're always going to use an index. What's the problem with that? Sorry? I mean, so someone needs to go ahead and create that index. And that means that every time that I want to make a query, every time I query, I'm going to have to go and create an index? Isn't that a lot of work? And who is going to maintain the index to be consistent with my code and all of that? This is actually how CouchDB works. RavenDB, on the other hand, goes like this. Okay, you gave me a query. I look at the query, and then I have the query optimizer that is going to kick in. That query optimizer is going to analyze your query and says, ooh, that query belongs to this index, let's run it with that. But what if there isn't such an index? RavenDB basically says, okay, look, I have the database. I know what's going on. I know what index it would take to answer this query. I can create this index for you. So you don't have to think about indexes. You see this one? You don't have to think about indexes, but you still get all of the benefits of that. Now, indexes are really, really cool, but they have a cost associated with them. So you can see that this is a temporary index. RavenDB is going to keep it around in case we're going to have to query some more on this index. But if no one is going to be using this index for a while, that index is going to be terminated. We're going to garbage collect all of its resources, and that would be it. Everyone is happy. But what happens if you are using this thing? RavenDB is going to actually notice that and to say, okay, I see that you have an important index here. Even though it's a temporary index, it's important. I'm going to turn that from a temporary index into an auto index. An auto index is going to live for a very long time. It's going to have more resources than temporary index. And basically, based on the actual analysis of your production behavior, RavenDB can create the indexes that you need for you on the fly without needing to do anything at all. It's actually, we actually take it several steps beyond that. Even after you have the indexes, RavenDB continues to monitor the level of activity that you have in those indexes. And the more that you query on an index, the more important it becomes, the more resources it will get from RavenDB. By the way, I'm literally have I don't have a lot of time, so I'm skipping through things very rapidly. Now, index sounds scary sometimes because you deal with low-level stuff and bit trees on the disk and all sorts of stuff like that. With Raven, this is what an index looks like. What is this index? It's an inquiry. Go over all of the courses and index their tags. That's about it. Now, I'm actually going to take us to a different database. I think I have another 10 minutes, something like that. I'm going to ignore the time limit, but nevertheless. Let's use some sample data. So here is some sample data, albums. And I want to, so far we talked about, okay, let's make some queries. Let's make queries such as, okay, all courses by tag. We could have searched by a user, by with a specific requirement, all sorts of stuff like that. But let's take it several steps ahead of us. What sort of queries can I do on a document like this? Give me an option. I'm sorry. Give me an option. Yes? Can't hear you. The most expensive album. Okay. Let's see that. So this is actually not a complex query at all. All I have to do is say something like this. You know what? I don't think that I even need that. Albums, add sort by a price desk. There is no expensive album, but that would give it to you. See that? So, and then we don't have a way to limit the result in the UI, but this is basically what you do. But let's do something that is actually quite hard to do. What I want to do now, look at this. What I want to do now, you see that we have the artist. I want to get for each artist count of albums, most expensive album. What else? Sorry? The title? Price, title. How expensive would it be to do that? Not for a single artist, but for all artists. Let's say that I want to show you a UI like this for all the artists. And you see, I want to show you things like that. So this is the number of albums he has, this is the number of songs, this is the most expensive song, this is the title of the song. If I was doing that and I'm not doing that on a single item, doing that all of them, that would be very expensive to do. But in Raven, I'm actually going to do that using something that is called MapReduce. How many of you heard MapReduce? How many of you are scared by it? Yeah. Okay. MapReduce is a technical term for something you might have heard about before. This is what MapReduce is, essentially. So let's look at what we are doing. We're going to create a new index. And we're going to try to yes, it went to the wrong database. Okay, so we're going to try to pick up a few things. So from album in docs.albums, nothing special so far. Select new. A.artist, artist.id, artist name. Okay, now I want the price. Most expensive. And count equal 1. Yeah, it looks good. This looks strange, right? What is this thing that I'm doing in here? This is part of a MapReduce operation. MapReduce always come in 2 steps. Let me show you how it would look like if I was doing that in 1 step. Artist ID equal G dot key, artist name equal G dot most expensive G dot order by descending, first, and count equal G dot count. This is a long link query, but you follow what's going on? Good. The problem with this sort of link query is that every time that one of the albums changes, I have to recalculate that for the whole data set. So instead of breaking it apart into 2 smaller operations, this one is the first operation, and an additional reduce. And the reduce is going to look like this. And because we are doing that in multiple operations, I have to do it like this. Oh, we have errors. Yeah. Stupid. Sorry, it's like this. Oh, we still have errors. Yeah, 1 second. The nice thing is that we get good errors when we make stupid typos. You see what we have now? So now we have, it would probably be easier if I do it like this. Now we have, for all of the artists, all of this information. I think that AC/DC has, you see they have 2 albums, and Let There Be Rock is the most expensive one. You know what? Let's play with this one. Let's go to letter B rock and change it a bit so it wouldn't be the most expensive one. It would help if I knew what title. Now let's change it to be 590. The best of Billy Coham. No, wait, where is ACDC? Oh. What actually happened here is that this is, we didn't specify a sort order, so it just did it by forced right. So we actually need to do it like this. Artist name, ACDC. Okay, so you see that it changed. And a couple of very interesting things about what we did. We defined an index, a map-reduce index that went over and did aggregation over the whole data set. Now, what is the output of this index? Anyone? A new data set, and it's pre-computed. When I'm making this query, how expensive do you think this query is, by the way? Anyone wants to take a guess? How expensive is this query? Let me just show you what I mean by that. You see this number? This is 2 milliseconds. And the fun part is we have the index. When we define the index, we actually run it in the background and create our own data structures. When you count the times and you want to query, we don't do any computation whatsoever. Because we don't do any computation whatsoever, what's going to happen? All we have to do is literally run over the already pre-computed data. It's already sorted based on, it doesn't matter. The important thing is that we can search over that data because we store it in an efficient manner very, very rapidly. And then we give it this value. This is why we can do that in very few milliseconds. This is why we can do that even on very large data sets. Just to give you some idea, and mostly because I'm running out of time, a few weeks ago, the guys from NuGet posted that they have some sort of a problem with performance with NuGet. And I decided that I'm going to take the NuGet dataset, pull it into Raven, and then see how it works. And I have a whole series of blog posts about that. But what I want you to see is this thing. This is the result of perf testing that we just did with the full data set for NuGet. Let's see if I can switch it. Do I have something slightly? No, it appeared that I have only 250. So, interesting enough, what is the green thing? So, let's look at this. The red thing, this is the most important thing. This is the number of users. 1 second. No, it's not the number of users. It should be, but it's, oh, yeah. Yeah, it's the number of users. And you can see how it goes. It goes up, and then it stables on 300 users. Then we have the green part. The green part is number of pages per second, which is nice at the average of 77 pages per second. What is the blue thing? Yeah. Average response time. You see that we move from, I think we started with 20 users to 300 users. And this is how it looked like in terms of the response time. The max response time that we had, 20 milliseconds. The average response time, 6 milliseconds. This is not me playing around with databases that have a couple of hundred records. This is the full NuGet dataset running under full load test. This is the result. And just to make things a slightly bit more interesting, do you know what happened? What happened if you run a perf test on 300 users and it works just fine? What's the next thing that you're going to do? How many users? Now you can see that things have gone slightly worse for Raven. We started from 200 users all the way to 3,000 users. This is still pages per second, and the average is 741 pages per second. Average page, by the way, look at the load. This is how fast we're able to process requests. This is the number. 300 milliseconds, 400 milliseconds, I will push it, 400 milliseconds. And a load of 3,000 users. You know what the really fun part is? Remember the code that you just wrote? The one about, the one to demo you how to use RavenDB? Now, all of you wrote this sort of code, right? This is not production code. You would never go with code that simple to production, right? Let me show you what is the code that we used to do this. This is the NuGet perf, NuGet web, controller. Can you read the code? Is it visible? So here is the code that we used to demonstrate for a perf test, which is the same code I showed you earlier, which is also best practice code. So one of the things that we really focused with RavenDB was, I know how complex it is to build good data-driven applications. I've been doing that for 15 years. So with RavenDB, we set out explicitly to say we are not going to repeat a lot of the old mistakes. So the API, by design, the simplest thing you write is also the best thing you write. It, as you can see, can scale pretty much to ridiculous levels. And you don't have to worry about things. That's probably the most important things that you have to remember. With RavenDB, we follow two mantras. Safe by default, and it just works. And I'm pretty much sure that we've gotten a lot of that actually working.